A Chinese electric car just landed in Germany that has Tesla and BYD engineers genuinely worried. It's called the Leap Motor C10, and it's doing something that shouldn't be possible at its price point. While most affordable electric cars force you to choose between range, features, or charging speed, this little machine refuses to compromise on any of them. The company behind it appeared out of nowhere, sold almost 300,000 vehicles last year, and just partnered with one of Europe's biggest automakers to bypass the usual decade-long struggle of building a dealer network. So I'm breaking down everything from how this unknown Chinese startup pulled off this engineering feat, to what battery technology they're using, to whether this car can actually deliver on its promises in the real world. The stealth invasion? Leapmotor isn't some century-old automotive giant. The company only started in 2015, which in car manufacturing terms makes them practically a toddler. But here's where things get interesting. While most Chinese EV makers spent years trying to convince European regulators and customers to trust them, Leapmotor took a completely different approach. They walked straight into the offices of Stellantis, the massive conglomerate that owns brands like Jeep, Peugeot, and Fiat, and made them an offer they couldn't refuse. The deal was simple but brilliant. Stellantis would get access to Leapmotor's affordable EV technology and platforms. In return, Leapmotor would instantly gain access to hundreds of established dealerships, service centers, and supply chains across Europe. No years of building trust. No expensive infrastructure investments. Just instant legitimacy. This partnership meant that a brand new Chinese company could open bookings in multiple European countries almost overnight. The move caught everyone off guard because it solved the biggest problem facing Chinese EV makers, which is that Europeans are hesitant to buy cars from brands they've never heard of, especially when service and parts availability are question marks. But when you roll into a Peugeot dealership that's been serving your town for 40 years and they're selling you a Leapmotor with full warranty and service backing, suddenly that hesitation disappears. Leapmotor's strategy from day one was built around a single idea that sounds obvious but proved revolutionary. Electric cars shouldn't just be toys for wealthy people in California. They should be practical, affordable options for regular families who need to get to work and take kids to school. So while Tesla focused on performance and luxury, and traditional automakers tried to convert their existing platforms, Leapmotor designed everything from scratch with one goal in mind: maximum value per dollar spent. This philosophy shaped every decision they made, from engineering to manufacturing to pricing. And it's exactly why their cars started selling like crazy in China, where price-conscious buyers appreciated getting premium features without premium price tags. The numbers game? Let's talk about what the C10 actually costs, and why that number is causing panic in boardrooms. The base model starts at around 20,000 euros in European markets. To put that in perspective, a Tesla Model 3 costs nearly double that amount. The BYD Dolphin, which was previously considered the affordable option, still runs about 30,000 euros. Even the MG4, which carved out a niche as the budget-friendly European EV, can't match the C10's starting price. But here's the thing that makes this genuinely scary for competitors. Cheap cars are supposed to feel cheap. That's the unspoken rule of the automotive world. You pay less, you get plasticky interiors, buzzing speakers, uncomfortable seats, and a general sense that you bought the economy option. The C10 breaks this rule completely. Step inside and you're greeted with dual large digital displays that look like they were pulled from a car costing twice as much. The dashboard materials don't feel like hard plastic. The stitching looks deliberately crafted rather than hastily assembled. The seats offer actual support instead of just being flat cushions wrapped in fabric. And the build quality produces that satisfying solid thunk when you close the door, not the tinny rattle of cheap metal. This is the part that has established automakers genuinely concerned. For decades, they maintained clear tiers. Budget cars felt budget, mid-range cars felt decent, luxury cars felt premium. Everyone understood where they fit. But Leapmotor is delivering what feels like a mid-range car at a budget price, which completely scrambles the traditional value equation. The exterior design follows the same philosophy. It's not trying to be flashy or make bold statements. Instead, it features clean lines, smooth curves, and a minimalist front end that looks modern without being aggressive. The headlights are sleek, the body panels fit together properly. The proportions are balanced in a way that makes the car look more expensive than it is. And critically, the aerodynamics were designed to minimize drag, which directly translates to better range. Every curve serves a purpose beyond just looking nice. It's functional design executed well. The compact dimensions make it perfect for city driving. Parking is easy. Navigating tight streets doesn't require military precision, but it doesn't feel cramped inside because the interior space was intelligently designed. The front seats offer plenty of legroom. The back seats comfortably fit 2 adults. Storage spaces are thoughtfully placed throughout the cabin. For a small family or a couple, this car provides exactly enough space without the bulk that makes urban driving a headache. The battery breakthrough? Now we get to the part that really matters: the battery. Because you can make a car look nice and price it affordably, but if the battery is garbage, none of that matters. Electric car batteries basically come in two main varieties these days. There's NCM, which stands for nickel cobalt manganese, and there's LFP, which stands for lithium iron phosphate. NCM batteries pack more energy into less space, which is why performance-focused cars use them. But they're more expensive and slightly less stable. LFP batteries are cheaper, safer, and last longer, but traditionally they've been heavier and provided less range. Leap Motor went with LFP for the C10, which makes sense for a budget-focused car. But here's where they got clever. They didn't just use standard LFP cells. They implemented high-density LFP technology that packs more energy into the same space. This is the engineering equivalent of fitting more passengers on a bus without making anyone uncomfortable. The result is a battery pack that delivers between 420 and 530 kilometers of range, depending on the model you choose. Let me put that in context. The original Nissan Leaf, which was considered revolutionary when it launched, offered about 150 kilometers of range. Early budget EVs struggled to break 300 kilometers. Even today, many affordable electric cars top out around 350 to 400 kilometers. The C10 is matching or exceeding the range of cars that cost significantly more. But raw range numbers only tell part of the story. The real question is what happens to that battery over time. Most EV owners worry about degradation, which is the gradual loss of battery capacity over years of use. It's like how your phone battery doesn't hold a charge as well after 2 years of daily use. Leap Motor designed the C10's battery management system specifically to minimize this degradation. The battery pack includes sophisticated temperature control that keeps cells at optimal operating temperatures. When it's hot outside, cooling systems prevent overheating. When it's cold, heating elements ensure the battery doesn't lose efficiency. The system constantly monitors each cell group and balances charging to prevent any single section from wearing out faster than others. This engineering might sound boring, but it's actually critical. It's the difference between a car that still delivers 90% of its original range after 5 years versus one that's down to 70%. And because LFP batteries are inherently more stable than NCM, the fire risk is significantly lower. LFP cells don't suffer from thermal runaway as easily, which is the technical term for when one cell catches fire and triggers a chain reaction. For families worried about safety, this matters a lot. The battery positioning also deserves attention. It's mounted low in the chassis, which drops the car's center of gravity. This isn't just about handling, though it does make the car more stable in corners. It's also a safety feature. In a side collision, having the heavy battery pack low means the car is less likely to roll over. The whole structure was designed to protect the battery in an accident while using the battery's weight to improve driving dynamics. The voltage revolution. Here's where the C10 does something that shouldn't exist at this price point. It runs on an 800-volt architecture. Most electric cars, including expensive ones, use 400-volt systems. To understand why this matters, think about water flowing through pipes. A 400-volt system is like a standard garden hose. An 800-volt system is like a fire hose. Same water, but it flows much faster. In practical terms, this means the C10 can charge at speeds that embarrass much more expensive vehicles. Park it at a fast charging station and you can add 200 to 250 kilometers of range in about 15 minutes. That's enough to grab a coffee, use the bathroom, and get back on the road for another 3 hours of driving. Compare that to 400-volt cars, which need 25 to 35 minutes to achieve similar results. The time difference might not sound huge on paper, but anyone who's taken a long road trip knows that charging stops are the most annoying part of EV ownership. Cutting that time in half fundamentally changes the experience. Tesla has been dominating the EV market partly because their supercharger network makes long-distance travel feasible. But even Tesla's current production cars mostly run on 400-volt systems. The Model S Plaid uses higher voltage, but that's a 6-figure performance car. Finding 800-volt architecture in a €20,000 vehicle is genuinely surprising. The faster voltage flow also reduces heat generation during charging. When electricity moves through any system, some energy converts to heat, which is wasted energy. Higher voltage means less current needed to deliver the same power, which means less heat and less energy loss. This makes the whole system more efficient. The battery stays healthier because it's not being stressed as much during rapid charging. And efficiency gains mean you get slightly more range from the same battery capacity. The 800-volt system also makes the car feel more responsive when driving. The motor can draw power more quickly, which translates to snappier acceleration. Press the accelerator and the car responds immediately without the slight lag some EVs exhibit. It's not about raw speed, though the C10 can hit 100 kilometers per hour in around 7 seconds, which is perfectly adequate. It's about how the car feels in daily driving. Merging onto highways is effortless. Overtaking slower traffic doesn't require planning. The power is just there when you need it. For home charging, the C10 works perfectly fine with standard equipment. Plug it in overnight using a basic wall charger and you wake up to a full battery. The car doesn't need expensive specialized home charging infrastructure. This matters because one of the hidden costs of EV ownership is often the charging setup. If you can just use a regular outlet or a cheap level 2 charger, the total ownership cost stays much lower. The reality check: numbers and specifications only reveal so much. The real test is what happens when regular people drive this car in real conditions. Early reviews and user reports from China, where the C10 has been available longer, provide some interesting insights. The claimed range of 420 to 530 kilometers holds up reasonably well in real-world driving. In mixed city and highway use, most drivers report getting between 350 and 400 kilometers, which represents about 75 to 80% of the official number. That's actually pretty good. Official range figures for EVs are tested under ideal conditions that don't match reality. Gentle acceleration, moderate speeds, perfect temperatures. Real driving involves traffic jams, highway speeds, air conditioning, and heating, all of which drain the battery faster. Getting 75 to 80% of the claimed range in daily use is considered solid performance. Highway driving at sustained high speeds does impact range more significantly, as it does with every EV. Drive at 120 km per hour for an extended period and you'll see the range estimate drop faster than the distance covered. This isn't unique to the C10, it's basic physics. Air resistance increases exponentially with speed, so cruising at 120 requires much more energy than cruising at 90. But the 800-volt fast charging capability compensates for this. You can stop, rapidly top up the battery, and continue without massive delays. City driving is where the C10 really shines. The compact dimensions make parking and maneuvering easy. The instant torque from the electric motor makes navigating traffic smooth. And because you're not burning fuel while idling, sitting in stop-and-go traffic doesn't feel as wasteful. The regenerative braking system, which captures energy when you slow down and feeds it back to the battery, works well in urban environments where you're constantly speeding up and slowing down. The suspension tuning strikes a reasonable balance. It's soft enough to absorb bumps and potholes without jarring passengers, but firm enough to keep the car stable in corners. You're not going to confuse this with a sports car, nor should you expect to. It's tuned for comfort and practicality. On smooth roads, it feels refined. On rough roads, it doesn't beat you up. That's exactly what a family car should deliver. Interior noise levels are kept reasonable through decent insulation. Wind noise at highway speeds is noticeable but not intrusive. Tire roar depends partly on which tires come equipped, as budget tires tend to be louder than premium ones. But overall, conversations in the cabin don't require raised voices, and the audio system doesn't need to be cranked up to overcome road noise. The climate control system works effectively. The heat pump technology used in modern EVs, including the C10, is more efficient than traditional resistive heating. This matters because heating the cabin in winter can significantly impact range. A heat pump uses less energy to achieve the same comfort level, which means your range doesn't tank quite as badly when temperatures drop. Cold weather still affects battery performance, as it does with all EVs, but the impact is less severe than it would be without proper thermal management. Safety features include multiple airbags, electronic stability control, and a body structure designed to absorb and distribute impact forces. The car has undergone safety testing to European standards, which are quite stringent. Advanced driver assistance features vary by trim level, but can include forward collision warning, lane departure alerts, and automatic emergency braking. These aren't revolutionary technologies anymore, but having them standard or available in a budget EV is noteworthy. Many affordable cars still charge extra for this equipment or don't offer it at all. The market earthquake? The arrival of cars like the Leap Motor C10 represents something bigger than just another model entering the market. It signals a fundamental shift in what's possible at different price points. For years, the EV market operated on a clear premise. Affordable electric cars were compliance vehicles, minimal effort machines that manufacturers built primarily to meet regulatory requirements. They had limited range, basic features, and felt like compromises. If you wanted a good EV, you paid premium prices. Tesla established this dynamic. The Model S cost nearly $100,000 when it launched, but it was genuinely impressive. It proved EVs could be desirable, not just environmentally responsible. Other manufacturers followed similar paths, positioning electric vehicles as premium products. This made business sense because batteries were expensive and margins were thin. Charging premium prices helped cover development costs. But it also meant EVs remained inaccessible to average buyers. The C10 and similar vehicles from Chinese manufacturers are breaking this model. They're delivering genuinely competitive products at prices that undercut European and American offerings by 30 to 50%. This isn't dumping or selling at a loss to gain market share. Chinese EV makers have developed efficient manufacturing processes, secured battery supply chains, and designed products specifically for cost-effectiveness. They're simply operating with different economics. The immediate impact is pressure on established manufacturers. BYD, which recently overtook Tesla as the world's largest EV seller, already forced price cuts across the industry. Now, smaller brands like Leapmotor are attacking the budget segment that traditional automakers have largely ignored. Volkswagen, Renault, and others have budget EV models in development, but many won't arrive for another year or two. By that time, Chinese brands will have established market positions and brand recognition. The European Union is aware of this threat and has begun imposing tariffs on Chinese EVs to protect domestic manufacturers. But tariffs only slow the inevitable. Chinese EV makers are responding by building factories in Europe, which bypasses import duties and creates local jobs. Leap Motor's partnership with Stellantis is part of this strategy. They're not just importing cars, they're integrating into the European automotive ecosystem. The broader implication is that EV adoption will accelerate faster than most predictions suggested. Surveys consistently show that price is the primary barrier preventing people from buying electric cars. Range anxiety comes second, charging infrastructure third. The C10 and similar vehicles directly address the first two concerns. They're affordable and offer sufficient range for daily use plus occasional longer trips. As charging networks continue expanding, the third concern diminishes as well. When the financial and practical barriers fall away, the shift from combustion engines to electric power becomes inevitable. This transition will happen in waves. Early adopters already bought Teslas and premium EVs. The next wave consists of mainstream buyers who want electric but couldn't previously justify the cost. This is the market segment that affordable long-range EVs like the C10 will capture. Following that will be late adopters who switch only when electric cars become clearly superior in every measurable way, including price, convenience, and capability. We're currently in the early phase of that second wave. The technology has matured to the point where EVs work well for most people's needs. Prices are dropping to levels where they compete with equivalent combustion vehicles. And the charging infrastructure, while not perfect, is adequate in most developed markets. These conditions favor rapid growth. Analysts who predicted EVs would represent 30% of new car sales by 2030 are revising their estimates upward. Some now suggest 50% or higher is achievable if affordable models continue proliferating. The Leap Motor C10 matters not because it's revolutionary technology or because it will single-handedly transform the industry. It matters because it's proof that the economics of EVs have fundamentally shifted. Good electric cars at affordable prices are now possible. That genie isn't going back in the bottle. Traditional automakers must adapt or face irrelevance. And for consumers, this competition means better products at lower prices. The real winners are the ordinary families who can finally access electric transportation without paying premium prices or accepting major compromises. That's the genuine disruption happening right now.